going to talk about the hyperbola now. So here's the general formula for the hyperbola. You can see that the formula looks almost exactly the same as the ellipse. The only difference is that there's a negative sign. So ellipse has an add sign versus a hyperbola has a subtraction sign in between. Okay, that's the only difference between the formula. Okay, so let's analyze it. We're going to do the same kind of front work as ellipse. The center is HK. Our A is going to be the distance out left and right from the center, and B is going to be the distance out from the center up and down. So here's an example. Y plus, oops, sorry, I wanted to do an X there. X plus 1 squared over 9 subtract y plus 2 squared over 25 equals 1. Okay, so center, that's -1, -2, opposites. And from the center, we're going to move it 3 left and right, and we will go 5 up and down from our center. Okay, so graphing. -2, oops, sorry, -1, -2. So X marks that spot. Okay, I'm going to go 3. So 1, 2, 3 left. 1, 2, 3 left and right. Okay, and I'm going to go 5 up. 1, 2, 3, 4, 5. And 5 down. Okay. Now, before ellipse, we would have just connected the 4 points, but that's different in a hyperbola. You actually don't want those 4 points particularly. You are going to use those to make box. So my box corners would go there, 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 and there. Okay, so make a box, and now you're going to draw asymptotes that go through those corners, and obviously also through the center. Okay, so you might get asked the slope of the asymptotes, and the answer to that would be that the slopes are -b over a. So if you look at this line right here, you're going up 5, right 3. And this one, you would go down 5, right 3. So you can see the slopes are 5/3 and -5/3. So that's where this comes from. B, 5, 3. Okay? Now, hyperbolas can happen in 2 different ways. You could have an opening where they open left and right, and that would be if they have a positive x squared. They could open in an up-down way, and that's if they had a positive y squared. Okay, so what do we have? We have a positive and on our x squared, right? Our y squared part is the subtract part. So we are going to be doing this one. Okay, so this is going to be the vertex, and it's going to approach the asymptote. And remember that when you get to asymptotes, that they approach asymptotes. They don't cross over them. This is not going to look like a parabola, right? We don't do a parabola, we approach the asymptote. Okay, when you are done this, if you have points here and here, you will need to remove them because they're not part of your graph. So you need to erase those. If you get asked for your vertices, this one would be 2, -2. And this one would be 1, 2, 3, 4, -4, -2. Okay. If you get asked for your domain and range, you could possibly get asked that. So let's do range because it's easy. We'll go forever down and forever up. And domain. So this one looks different. For your domain, you're going to go forever left, up until -2. And then union, it's going to connect back up and go from 2 and on. Okay, so obviously if you had one that looked like this with the positive y squared, then you're talking about these kind of being opposite, right? Your range would go from -infinity to a number and then a number to infinity.